Okay, so let's talk about neurotransmitters in a little more detail. So this picture here should kind of remind you what we learned yesterday. So an action potential, right, which is electrical, is coming down the axon, right? It comes down here to the terminal part here, the terminal clef. And that causes calcium, right, to go inside and change the voltage. And the inside here is actually filled up with neurotransmitters, which are special chemicals. And those chemicals then fuse with the membrane, and the chemicals enter into this synaptic area, or the synaptic cleft. They diffuse very slowly across here, and they make contact with receptors here. Maybe this is another nerve, for example. And that causes sodium to enter in, which depolarizes this postsynaptic neuron and causes a new action potential to get started. So this is electrical, chemical slow, and then electrical fast again. Okay, I'm going to go ahead and erase this though, and let's take a little closer look though at these neurotransmitters, right? So there's all sorts of neurotransmitters that are filled up in this area here, and they're going to chemically diffuse across here and start a new action potential on the other side. Now, what could change this whole situation here? So we want the neurotransmitters to go across, but what if some sort of chemical came along that increased or decreased the amount of neurotransmitter? So the neurotransmitter is here. What if there was a chemical that came across here from somewhere else, right, that increased the amount of neurotransmitter that went here? Or, conversely, what if this chemical came in here that decreased it? So that would change the amount of activity that would be on the other side. Okay, so you might have somebody else coming in there. That's one possibility. What's another possibility? Let's take a look. Oh, we don't want to use that. How about this guy here? What if you get some special chemical that comes across here that will actually compete with our neurotransmitter? So let's go back here. So the neurotransmitter is supposed to be going across here, but what if you get some chemical that comes across here that says, I'm going to stop you, I'm going to compete with you for these receptors here? That would decrease the effect of that chemical. So that's the second possibility. Third possibility here. Let's go back and see what the third possibility is. Oops. Sorry, can't get it up. There we go. Okay, so third possibility here, if we go down here, is what if we get somebody who blocks the receptors? Then the neurotransmitter would not work very well at all. And the fourth possibility is, remember, after this whole thing is finished here, the neurotransmitter is supposed to be recycled, right? So it's sitting on these receptors, but it's supposed to be recycled, so it's reloaded here so it can be used again. What if somebody came along and stopped it from recycling? That would increase the activity of it down here. Let's just review those one more time, how we could change the effect of a neurotransmitter. You could increase or decrease the release of it. You could have some other chemical who could compete with the neurotransmitter. That would decrease its effect. You could have some other chemical that could block the receptor, or you could have somebody who could block the uptake or reuptake of the neurotransmitter back to the original guy. Who are these guys that might be changing all this stuff here? Well, we'll get to that in a second. Let's just talk about who they could be changing the effect of. So the synapse is between a nerve and somebody else, but it doesn't necessarily have to be another nerve. It could be another nerve, but maybe the guy on the postsynaptic area is a muscle, maybe it's a gland, or maybe it's actually your brain. These could be nerves running into the brain. And now, who are the neurotransmitters? Okay, here's just a partial list of them. So let's go through them. There are more, but this is a good start here. So acetylcholine. I know that's hard to say and it's hard to spell here. Acetylcholine. That's somebody who affects your muscles. Then there's norepinephrine. You know norepinephrine as adrenaline, right? That's somebody who affects your sympathetic system. That is, makes your heart go faster, makes you sweat, things like that. These guys are pretty much found out in the body. Then there's guys who are found in your brain, right? There's dopamine. Dopamine is the guy who is the reward neurotransmitter. What do I mean by that? Well, it means that when you release dopamine, you just feel like, wow, whatever I'm doing, it must be the right thing. It's a reward. It's kind of a pat on the back. Then you have GABA. Now, GABA is the major inhibitor. So it actually acts on other cells to stop them from releasing neurotransmitters. And the opposite guy to GABA is glutamine. And glutamine is the major excitatory neurotransmitter, which means that when you release glutamine, it causes neurons to release even more neurotransmitters. Okay, now we come to our friend serotonin, right? And serotonin is the guy who controls your stress levels. So anyone out there who's like OCD, something like that, or manic, depressive, whatever, they probably have serotonin issues. Then we got the endorphins. Endorphins are natural neurotransmitters that we release in our bodies that give us pleasure. They make us feel good. And here's two you might never would have thought about. These work out in the body too, not in the brain, obviously. These are caffeine and nicotine. You wouldn't think about it, but they're actually naturally produced. So these guys over here probably work in the body. So do caffeine and nicotine. And these guys over here, I'm going to do a different color here. These guys probably work in the brain. Okay?